Welcome back, everybody. This lesson is basically purely informational. So, if you remember from the beginning of the year, we talked about these different types of numbers, just the vocabulary of them. Counting numbers are the numbers you use when you're counting. So 1, 2, 3, 4, 5, 6, 7, 8. We don't count negative numbers. We don't count zero. So it's just those whole numbers that you count. And then whole numbers is basically all the counting numbers, and they just add zero. Then we get to integers, where it's all the counting numbers and all the whole numbers and their opposites. So we have whole numbers, 0, 1, 2, 3, and the opposites of them, which means negatives are involved. So as you see, every single time, the group gets a little bit bigger. So counting numbers don't include 0. Whole numbers are like, okay, fine, 0, you can come in. Integers are like, okay, fine, we'll take the negative numbers too. And then rational numbers is where they let a bunch of numbers come in. So rational numbers, the definition is that they can be written as a ratio. That's why they're called rational numbers. And if you remember ratios, we write like fractions. Okay, negatives are fine. So I know we didn't put negatives here, but negatives are fine. And this is what they say. They say that a ratio or that a rational number can be written as A over B if B does not equal 0. Because if you look on your calculator, if you ever try to divide by 0, it's going to say undefined. You cannot divide by 0. I've given this example, I think, a couple times. I don't know if I've given it to you, but I'm going to now. If I was given $1 million and they said, okay, you can only keep this $1 million if you divide it amongst your children. They're going to take it away because I have 0 children. I cannot divide $1 million among my children if I don't have any. Now, if it was my class students, then y'all would get money, but you can't divide anything by 0. So a rational number can be written as a fraction if the denominator does not equal 0. And then this is what I want you to know, because this is a better way of understanding it, so when you see something you can tell rational or not. Rational decimals terminate or repeat. And I want you to think of what that means. Terminate means it ends. You know how pi never ends? This is a pi that does not end, 3.14159, and some of you know more. We listened to the song on Pi Day. It just keeps going and keeps going. That's why it's called an irrational number. But rational decimals terminate. Look at 1/4, 0.25, and that's done. Repeat, 1/3. You see how these are written as fractions? 0.3 with a line over it and repeats. So it's okay. It's rational if it repeats or if it terminates. It's not rational if the decimal just keeps going and keeps going and keeps going. Sometimes when you have to divide 2 decimals on your calculator, you end up with like this crazy long whatever. But if you divide a fraction with a whole number on top and whole number on bottom, then you end up with something that either terminates or repeats. So we'll move on from that. Make sure you either have this written in your notes or something. I don't know what you're doing these days, but that's important to know these like definitions. So there's only a few couple examples on here. There's only a couple examples on here. Let me grab my example paper. Example 1 says, graph integers less than 4. So here we go. Integers are only represented by those numbers. You know what I'm saying? It can't be anything in between. So 1, 2, 3, 4. -1, -2, -3. Okay, integers less than 4. So 4 isn't part of it. But 3 is, and 2 is, and 1 is, and 0 is, and -1, and so on and so forth. Why didn't I just draw a line? Think for a second. Yes, that's right, because this is not an integer. That would be like what, 2 2/3? 2.7, right? That's not an integer. Only the actual numbers are integers. So we have to draw the dots right on the numbers. Okay, so that's number 1. Example 2 says, all whole numbers are integers. So if you think about it, remember we have the counting numbers, then the whole numbers, and then the integers. So the whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. Integers are all of those plus their opposites. So yes, all whole numbers are integers. And then the last one, are all rational numbers integers? Think about it. That doesn't even make sense because remember we said rational numbers could be repeating decimals, they could be terminating decimals, and those are not integers. So rational numbers are not integers, but all integers are rational numbers. So think of it as like the circle gets bigger every time. First it's just counting numbers, then they allow whole numbers, then they allow integers, and then rational numbers. And irrational numbers, nobody wants those except for us because pi. But you know what I'm saying, they're not involved in that group with rational numbers. So that's it, that was basically informational. If you have any questions, there are like some diagrams in the book that may help, but have a good day.